Hello, Philip.
Hi, Vera.
Obviously, we are in a very cold place in Iceland. We just tried to find a location sort of related to your ice cube neutrino observatory. You are a physicist and involved in many really interesting experiments and research. Who are you, Philip?
I'm a scientist.
Yeah.
I work on some very special particles we call neutrinos. I try to find out everything there is to find out about these particles,
Uh-huh.
and that's basically my job that I do every day.
Mhm.
And besides that, yeah, I'm a dad. I have a little daughter and a
Uh-huh.
wife at home, and yeah, that's pretty much my life.
When you tell this, it sounds quite normal, but I try to inform myself about your neutrinos. Just could you please explain for normal people with normal understanding what you do, what they are?
Yeah, so I mean, if you look at everything that surrounds us, it's
Yeah.
made out of tiny particles.
Mhm.
And probably most people know what an atom is. It's the
Yeah.
smallest possible division of the material that
Uh-huh.
surrounds us. And then if you go even further down into an atom, there are more small fundamental particles, we call them. And it turns out there's not only these particles that we see every day and that we feel, but actually most particles, we don't really see them. And neutrinos are a big part of those. So they're everywhere, they're surrounding us, they're flying through us all the time. But in our daily life, we don't get to feel or see them.
So
And
sorry, you tell me, when we two sit here,
yeah,
all these neutrinos just fly through us.
they come from above our head, they come from below, they come from all
Oh,
of the
they
sides, and
come
they just go through
from
us.
everywhere,
They
and we
go
don't
through the whole planet Earth and out on the other side.
know.
Yes,
They are also outside our planet.
everywhere. And we see them coming from beyond our galaxy, and they come and they penetrate everything. And it makes them very interesting subjects to study.
Yeah, it sounds like it.
Especially some of these neutrinos, they are believed to come from extremely far away. So they're kind of, we call them cosmic messengers. They come
Mhm.
from billions of light years away, maybe towards us. And if we can measure them, we can find out something about our universe a long time ago.
That was my interest because doing research when I hear you must be very fascinating. You are enthusiastic, but for us, why should we know about neutrinos? What do we get to?
So, I mean, there are two sides to this question, I think. If you ask, in a sense, what are they good for?
Yeah,
Not really much, right?
yeah, but many things, most of the
Yeah,
things.
but I mean, they give us a much more fundamental understanding of how our universe works.
Oh,
And I think if that's a question that is interesting to us, then we
yeah,
need to
I would
research
say so.
neutrinos.
So we should know about
Yeah,
neutrinos.
absolutely.
And you have this huge project down on Antarctica.
Yeah.
What do you do there?
So the problem with the neutrinos is that they're very hard to detect
Hmm.
because I mentioned before, they're just flying through everything,
Uh-huh.
which means they don't interact at all. And we have to go to quite large extremes to get to catch these neutrinos.
Uh-huh.
And there are laboratory based neutrino experiments that you can buy in the lab up to a certain size. But you can imagine if it's a very rare interaction of a neutrino,
Uh-huh.
you can increase your probability of detecting some by
Hmm.
just making your detector bigger and bigger and bigger.
Oh, okay. Yeah.
But at some point, it doesn't fit in the lab anymore, right?
Yeah.
So then basically, you have to go to nature and you have to build your detector into something that is already there.
Hmm.
And the way we detect these neutrinos is via their interaction. And in these interactions, they create what is called Cherenkov light. It's a very faint trace of like blue ultraviolet light
Uh-huh.
that we can then pick up. So basically, what you need is a very large volume of very transparent medium.
Okay.
And where do we have that? Well, it turns out at the South Pole, in the middle of Antarctica, Antarctica has a glacier that is almost 3 kilometers thick, and the deep ice there is ultra transparent. And it's deep, it's dark, it's very quiet, it's super transparent, so it's a perfect condition for
To
hunting
detect
these
these
neutrinos, right?
weird stuff not being seen, not be felt, nothing.
Yes, that's right.
So I think it's so amazing to be a researcher. And what do you think personally? Why you're able to do that? Because it goes over years without any result, or perhaps somebody finds out a week earlier. And what are your traits that brought you so far?
That's a very good question. I think you need to be quite determined, yes,
Yeah.
dedicated to the subject. And yeah, you need to have a long breath because, as you mentioned, I mean, sometimes you work on something for a year or even longer to either find out, oh, it doesn't work in the end, or someone else published before you,
Yeah.
or yeah, so you have a lot of setbacks to deal with. And yeah, the projects that we are working on, they're on time scales of tens of years. So yeah, you need, I mean, I mentioned before to you, I'm a very impatient person, but you need a lot of patience in that respect for the scientific results.
And perseverance.
Yes, absolutely.
And also courage, because dedicating such an amount of time of your life into something not secure, not being, you cannot be sure that you are succeeding. You have to be really stable also.
Yeah, well, I think at least for me, I'm very, I don't know, down to earth person. So in my free time, I just like to be at home with my family or to go camping or bicycling, things like this, you know. And so I think maybe it balances out these maybe more extremes on the research side. But then also when it comes to the day-to-day job that we're doing, it's not that extreme most of the time, right? It's very extreme if you go to the South Pole, of course.
Yeah,
If you
of
do
course.
things like that, if you have discoveries.
Uh-huh.
But then 99% of the rest of the time, we're sitting in our office, we're analyzing the data
Yeah,
that we took,
but
and we're trying to
still.
understand things. And so in that sense, it's maybe much more normal than it appears to some people.
Yeah, it appears to me, because you sit here in your chair, we are freezing to death, but you say, yeah, we have our results help to understand the universe. Who can say that?
Yeah.
It's really amazing, crazy thing. Um, when it's about your personality, you have a role model or an event that changed your life, or life changing book, or were you just straightforward from the beginning?
I don't have like this one aha moment, I
Mm.
don't think, no. I was always fascinated by these things, like to understand how things work. I mean, as a kid, I like to take stuff apart to see what's
Yeah.
inside and what's further inside and further inside. And in a sense, I maybe continue that in looking now into the atoms and even
Yeah.
further down,
Just the universe.
just to figure out how stuff works. Basically,
Yeah.
that's what's driving me, I think. And
And
basically, yeah, you want to figure out then in the end how does the universe work in a sense, right? It sounds very grand, but
yeah, it sounds really grand. And working along, and these neutrinos, they are nature. They are the nature, and obviously you are influenced. Is there other stuff that has impact on your life? For example, art, or just the beauty we have here?
yeah, I think so. I don't know if it's connected to being a scientist or maybe not, but maybe it helps to appreciate the beauty of nature even more. Perhaps, perhaps not.
Yeah.
But yeah, I really like also like seeing today these icebergs
Yeah,
here
it's
is just
quite
very
amazing.
inspiring and
Yeah, it's
amazing. Yeah,
inspiring.
that's right.
I would like to. You work at the university.
That's
You
right.
are a lecturer, professor, and you have these students. You even won an award. Um, if they ask you, do you give advice? If a student comes to you and says, "What should I do? How do I proceed? And what should I put weight on?" What do you say?
I think it's, yeah, in the end, it's a very personal decision what someone wants to do. And I mean, so there are a lot of people, I think, who want to do science and they're
Yeah.
interested in it, but maybe at some point in their life, it doesn't turn out to be the right thing for them.
Hmm.
Sometimes it's actually very sad to see you have very talented people and then they disappear to some industry job, we call it.
Really?
But it also has to do with things like maybe job security and security in life in general, because if you are into a career in science, it's a long time of very much uncertainty until you have a permanent position. And it's not guaranteed at all that you will succeed on this career path. And most of the time, I mean, it's kind of like, you could say it's kind of a pyramid, right? You have a lot of students and then you have maybe less PhD students and less of that, and there are fewer and fewer positions. So we work with a lot of students in our lab and a lot of PhD students, etc. But many of them, in the end, after maybe graduating with a PhD, then they go and take some other job in industry. They go to do all sorts of crazy things. It's also interesting to follow their career path. But it's not if you decide now, today, you want to study physics and you do a PhD, probably you will not end up being a professional scientist, I think.
Yeah. So being a scientist is also, it's part of. If you go to into industry, I think you earn more money.
That's for sure, yeah.
That's for sure. That might be also a reason for some. And it's the insecurity to reach the scientific results also.
Yeah, that may be, but I think it's more mundane. It's just having a guaranteed job. I think that is very insecure in science.
Okay.
Yeah.
And university, they have a straight hierarchy?
No, no, no.
No,
It's a very flat hierarchy.
really?
It's yeah.
If
At least,
you're,
I mean, I think it depends in what field you are in.
uh-huh.
In our field, in physics, is a completely flat hierarchy. In other fields, I have heard, for example, computer science or maybe medicine and other things like that. It's
Medicine is
very, very
very
hierarchical.
yeah, and
But for
straight,
us, we're all, no, it's
flat.
very flat hierarchy. And it's important because, you know, it's very dangerous if it becomes a hierarchical structure, then people stop questioning your
Uh,
decisions or intuitions, etc. And then it becomes a very dangerous undertaking because young people, they have their own ideas, they have their own views of things, and they maybe are smarter than you in a
yeah.
lot of things, right?
Uh-huh.
And so it's important that they are being heard and they can express whatever they want. And so in our field, I think in general, in physics, it's a very flat hierarchy. You can go any day to any professor and tell him, no, you're wrong. But like, oh, interesting. Why? Tell me why. I want to understand, right?
That flat.
Yeah.
You're just equal on eye
I
level.
mean, yes and no, of course. There's some
Yeah,
things that
of
you then
course.
can delegate to others, right?
Yeah.
But in the scientific sense, it's very flat. Yeah.
And what do you think? You have a daughter,
Yeah.
and you are into education, obviously. um, what where do you put the weight on there, or it's too personal to ask?
You mean in general for
Yes.
education? I mean, it's a very important aspect. And I mean, also kind of my job description
Yeah.
also allocates quite a bit of time for teaching and for education. And I think it's also important. Sometimes it's a bit of a burden because it takes a lot of time to prepare lectures, to give lectures, to organize exams, to do all of these things. But it's quite nice. I like the teaching part,
Hmm.
especially if you have students who are interested to learn.
Yeah.
And yeah, often you have that. And when you teach a subject, you get to learn about the subject again from a different angle. So I think it's always good. So it's probably a good idea since a long time professors do research, they also teach.
Yeah.
It's probably smart to do it that way. Yeah, but
And not to kill the passion.
yeah. But I mean, it's also important because we need to educate new people. And as I said before, maybe only very few of them end up doing science. But still, the education that we can provide, I think, is still very valuable, even if you then decide you go to do some very different job.
Yeah.
But at least to have the chance to, for a couple of years, to dedicate yourself to maybe natural sciences or another field, it's fine. I think it's quite important.
Yeah. So you have utopia. What should the world be like? Not as a scientist, just as human being. What would be the ideal world for you? How should we treat each other?
Oh, personally, I like to have a lot of freedom myself, and I believe others should have their freedom,
Yeah.
whatever that means to them. And in a perfect world, we wouldn't go and tell people what they should do or what they should believe, or
Yeah.
and not tell anyone who's wrong and who's right, but kind of coexist peacefully. I think that would
Respect.
be very ideal.
Yeah.
I know it's
Respect.
not possible, probably.
Yeah.
So,
We can work on it.
yeah. Yeah, well, right now it's a lot of work to be done.
Yeah.
Yeah.
And you're going again to this project in the Antarctica?
Perhaps. So I haven't planned myself a field trip because right now I'm needed at home with a small child, I think,
Yeah.
more. But we as a science collaboration, of course, we have permanent staff there at the South Pole around the clock, around the year. And actually next season, which is winter here, it's summer at the South Pole, we'll have a huge installation of new detector hardware
Yeah.
in the ice. And that will be quite a big undertaking. We're installing over 10,000 new sensors
In a
into the
bigger
ice.
area then.
No, actually in a smaller area.
How come?
So it depends which type of neutrinos that you want to measure. And by type, I mean mostly which energy of neutrino that you want to measure. Are you interested in the more high energy ones or in the low energy ones? And the upgrade of the detector that we're planning right now is focusing on the lower energy end because you can do very interesting science with those. And these lower energy neutrinos, they create much smaller traces of light in the detector. So we're actually going and in the heart of the existing detector, at the very bottom in the center, we're deploying a lot of sensors there. And that will enhance our capability of measuring the low energy spectrum of the neutrinos.
So interesting. And before we just lose our fingers, it's so interesting. But I wish you luck because I admire your strength to continue for with a prospect of 10 years or some luck. And thank you so much. It was really
Thank you.
interesting. Thanks, Philip.